Welcome to ACT Prep Day 35. Hopefully you have your slip for your bell ringer or just notebook and pencil handy to answer the questions. And here is our bell ringer for the day. This goes back to the lesson on geometric and arithmetic sequences to help establish a pattern and determine the next number in the sequence. So take about 5 to 10 minutes, pause the video, work on the answers, and when you're done, hit unpause and we will double check the answers. Okay, welcome back. Let's look here. If you look, in this first one, this is arithmetic. We just seem to be adding 4 to each one of the terms. So 8 plus 4 is 12. Here, this tends to be geometric. It looks like we are multiplying each term by 7. So 14 times 7 is 98. And the last one, we're multiplying by 2. So 8 times 2 is 16. Now, the second one can be solved one of two ways. I probably would just recognize that we are adding 4 to each term. That's our common difference, which is plus 4. And go 11 plus 4 is 15. 15 plus 4 is 19. 19 plus 4 is 23. Probably faster that way. Because the other way is to have the formula memorized. We know that the common difference is plus 4. And the formula is the first term plus whatever this common difference is times n minus 1. And n is the 8th term, so we're going to do 4 times 7. And you see we get the exact same answer, 23. And this last one, this one's pretty easy. You probably would not use the formula because if the first number is 5 and the difference is adding 5, I can count by 5s. 5, 10, 15, 20, 25. I got 5 of them, so the answer is that. Stop right there. Okay, let's get into surface area and volume. Surface area is not one of my favorites. It's not that it's hard, but it can be tedious. But there are special certain three-dimensional figures that make things easier. Like if there's a cube, we know that all of the faces are going to be the same. And so it would be 6 times Q of S. And I'm going to show you. Here's my Rubik's Cube here. Okay. It's got 6 sides, 6 faces. But because it's a cube, I know that each one of these sides are the same because all the sides have the same length. So I could technically find the area of the red side and just multiply by 6 because there's 6 sides. Now, if it was something different and the sides are not all equal, it's not going to be as simple as that. Okay? Like when we start talking about prisms, a prism would be like a box. This is an example of a prism. If you look here, it's got how many sides? 1, 2, 3, 4, 5, 6, 7, 8. This is an octagon. We would call this an octagonal prism. And the reason is this defines the shape. The sides are all rectangles. And I can take this figure, you can see here, the top and the bottom are the same. If I rotate it, is it the exact same? Yeah, it is. Now, the other type of figure we'll talk about are pyramids. And yes, I can solve all these. Here, this is an example of a pyramid. So you can see it has a point at the top. It's not like a prism because if I turn it upside down, it's completely different. It won't even stand up there unless I do this. Okay? So it's completely different. So on your pyramids, you're going to have triangles for sides, but the base here is going to determine what type of pyramid it is. This would be a triangular pyramid because it has a triangular base. You can have square pyramids where the base would be a square and you have 4 triangles for sides. That's actually what the Egyptian pyramids are. They are square pyramids. Okay, so let's go back to our PowerPoint. And it's going to talk about the prisms and pyramids, but I wanted to really give you a visual on what those look like. Now, if the figure's not given to you, draw it out. Like you've got to account for how many sides. I've got to know that this is going to have 4 sides that I have to find the area of. The cube has 6, and this one has, oh gosh, 8 sides plus the top and the bottom. There's 10 sides here that I've got to find the area of. And the top and the bottom would be the same, so I could calculate that. All of these would be the same, and all of these would be the same. So I at least have to do 3 area calculations. Okay, this is an example of a square pyramid. Again, it's different from the one I showed you because this base is a triangle and this one is a square. Now we've also talked about right circular cylinders, and sometimes the formula has been given on the test, but sometimes it hasn't. So it's really good to be familiar with it in case they remove it again. What is a cylinder, a right cylinder? I think of Pringles can. I think of a can of soup or SpaghettiOs with meatballs. This is a right cylinder because the sides are perpendicular to the base. It's a cylinder. The top and the bottom are the exact same shape, and it's a circle. So I can turn it over and stack it like this, and it'd be the same. And so the surface area for a cylinder is interesting. I'm going to take this sheet of paper here. Okay, I'm going to take this sheet of paper here. And if I take this rectangle and I put these two sides together, you would see I'm getting a cylinder. If now I had a top and I had a bottom, it's a cylinder. And so that's what we do. When we have a cylinder like this, and I can almost do it with this label. Let me grab my scissors here. If I took this label, it's stuck on there really, really well. I don't know if I'm going to be able to show it. Yeah, they stick it on there really, really well now. Okay, but if I took this label off, it basically would unfold to a rectangle. And that's where we end up getting this formula from, is that the surface area of a cylinder is going to be the area of the circle on the top, which will be the same as the one on the bottom. And then we have to unfold the sides, or like unfold this label, and we're going to get a rectangle. Now, the length and width of the rectangle, one is going to be the height of the cylinder. Okay, remember we unrolled it. And this length here is going to be the circumference of our circle. So the circumference here is going to be the length when I unroll this whole label. And so you can see our formula there. 2 pi r squared is going to give me the area of both the top and the bottom. And then for this unrolled part that's now a rectangle, the circumference is 2 pi r, and we multiply by the height. Okay. And these are usually the two measurements you're given. You're given the radius and you're given the height. Because if you look at the formula, that's all you need. It really is. Now volume. Whew. Volume is going to be, if I take this can of SpaghettiOs, how much is inside? How many ounces of SpaghettiOs and meatballs are inside? And this one says, ooh, 15.6 ounces. So this can will hold 15.6 ounces of SpaghettiOs. Okay? That's what we're wanting to know. If you poured it in, how much are you going to get there? Now, volume are 3 dimensions, and they're called 3 dimensions because that's what you're measuring: length, height, and width. Now, you're going to measure things like completely different depending on the way and shape of the figure. And I'll be honest, when I was getting my master's, I had to take a geometry test and know all the area and all the volume formulas. And I freaked out because it was just too many. But one of the things that I do is, if you look at the figure, okay, to find the volume, all I really have to do is find the area of the base and multiply it by the height. because it's basically circles that I just keep stacking on top of each other till I reach this point. And that helps me remember formulas. So what would be the area of this base? It would be pi r squared, and then times the height. So pi r squared times the height. Okay. If you're doing the rectangular prism, so something like this, I could do area of the base. If it's rectangular, it'd be length times width times the height. And that's where we get all of these from. So let's look at our ACT example. If you have a square cube, they want to know how long are the edges if the surface area is 1350. So pause the video, take about 5 minutes, and see if you can do this one on your own, and then unpause and we'll check the answer. Okay, welcome back, and let's look at the answer here. So if I have a cube and the total surface area is 1350, then I can find one side by dividing that by 50. Sorry, not by 50, by 6. Whew. So 1350, I'm going to divide that by 6, and you see that here, we get 225. So one side, this yellow side, has a surface area of 225. Well, I know this is a square. Why? Because you told me it's a cube. So that means that 225 is the area, and we get that by going side times side, or side square. So now we've got the equation 225 equals side squared, and all we have to do is take the square root of both sides, and the length of each one of these is 15. Okay, today we got 5 questions for you. So use the online stopwatch here, or use your own device to set a timer for 5 minutes. Work on the ACT practice problems, and when you're done, come back to me and we'll check the answers. Okay, welcome back. Let's look at what we've got here. So again, we have a cube. So I think of a Rubik's Cube, and it has a total surface area of 36x squared units. Which of the following expressions gives the area in square units of a single face? So all I'm wanting to know is the area of this face, like this yellow one. If the total surface area is 36x, there's 6 faces, so we need to divide by 6. That means that one face is going to have an area of 6x. It's an expression. We're not going to give an actual number, because until somebody tells me what x is, I have no idea. The best I can say is it's 6 times x. Now here you've got a circular cylinder. So it's like a can. It's like a can of soup, can of SpaghettiOs. And the surface area is 32 pi square units. The diameter, so all the way across, is 4 units. They want to know how tall it is. Okay. Now they give you a hint here. You get the formula. Okay. So let's just plug that in. 2 pi times the radius. Oh, we don't have radius, but we have diameter. How do I get the radius from the diameter? It's half. So radius is going to be 2. You got to make sure you do that calculation. So I have 2 pi times 2 squared plus 2 pi times r. What is that? Well, that's the radius again. 2 times the height. That's our unknown. So here we're going to get 2 squared is 4. 4 times 2, I'm going to get 8 pi. Okay. Plus 2 times 2 is 4 pi times the height. And we know that is equal to 32 pi. Now you're probably sitting here going, okay, how are they getting rid of the pi? Because none of the answers have it. Well, now we need to solve for h. And the first thing we do is we subtract 8 pi from both sides. I'm going to move up here. And we get 4 times pi times h equal to 32 minus 8 pi is going to give us what? 24. And then we divide both sides by 4 pi. And we get an answer of 6. Yes. Again, another reason why where you do not need a calculator and multiply by pi. Leave it as pi. And the last one we've got here, again, we got another cube. The edges here are all 4 inches long. So what's the surface area? Well, I have this memorized. I know I find the length of, or the area of my yellow side. So it's going to be side times side. So that's going to be 4 times 4. Tells me it's 16 square units for the yellow side. And the other 5 sides are the same. So all I need to do is multiply by 6. And you end up getting 96 square inches. Okay. 2 more. Oh, I thought we were done. Nope, we've got 2 more. That's right. There were 5. If a box has a volume of 2,160 cubic inches, they're telling you that each box is a rectangular prism. Okay, so we're going to have a top and a bottom, and the other ones will be rectangles. Since it's a rectangular prism, we know the sides, the top and the bottom, are rectangles. And those rectangles have a length and a width of 12 and 15. What is the height of the box? So this formula is basically just length times width times height. And it's going to equal 2160. We know that length is 12. We know that width is 15. We don't know height. And so equals 2160. So all we have to do now is take our calculator, 2,160 divided by 12 divided by 15. The other side is 12. And then the last one here, this is actually something that I do in real life. I want to garden, I want to add mulch, or I want to add pebbles somewhere. And I need to make sure that I buy enough, but I also need to make sure I don't buy too much and waste my money. So they want an area, and I'm visual. I'm going to draw it out. It's going to be 5 feet by 3 feet. And I'm already sitting here going, oh, that's 15 square feet in area. But since they want it to have a height here, oops, I probably should draw it that way, of 1 inch, now we're talking volume. They want to fill that rectangle up in inch. So now we have to do length times width times height. So 5 times 3 is 15. And then here's our problem. We can't just go 5 times 3 times 1 is 15. This is not correct because here we're dealing with feet and the height is in inches. We got to do conversions. And I would be the first one to go 5 times 3 times 1. Oh, yes, the answer's there. I'm right. No, you're not. Always check your measurements. So one way to combat this, since this is 1 inch, it's easier to convert these into feet. So 3 times 12 is 36 inches, and 5 times 12 is going to be 60 inches. Okay? Now again, it's saying how many cubic feet, though. How many cubic feet are we going to have? It makes it really tricky. We always could do 5 feet times...
Hey, Olivia, please come to the annex office. Your ride is outside.
We can do that, multiply 60 times 36 times 1, and then convert back to feet. But probably the easiest thing to do in this scenario, usually it's better to go from the larger conversion to the smaller one. I would end up taking this one and changing it to 1/12 of an inch. Of a foot. So now I can do 5 times 3 times, 1/12. And it's basically going to be 8 divided by 12, which gives you 1.25. You 1.25 cubic feet. Now, your exit ticket. Your exit ticket is talking about a rectangular solid and how if we just use a factorial to increase the lengths of the length, width, and height, they want you to be able to recognize what effect that has on volume. It's not simply, ooh, we doubled all the sides. Let's just double the volume. We multiplied all the sides by 5, so that is the volume times 5. No, it does not work that way, okay? And I'm going to give you a huge, huge hint. Let me get my whiteboard up. So we know that the surface area is going to be, type it up here, A equals 2, the length times width, because that's one of them, 2 width times height, plus 2 times length times height. So I'm just looking at this going, God, there's no numbers. There's nothing to compare. So let's look at our first one. Our first one, I am going to use numbers. So I'm going to do a rectangular prism that length, width, and height are all 1. And I'm going to calculate it. 2 times 1 times 1 is what? 2. 2 times 1 times 1 is 2. 2 times 1 times 1 is 2. 2 plus 2 plus 2 is 6. Now let's double all of those numbers. So we double them. That's exactly what the exit ticket is saying. So if I double 1, that's going to give me 2. And let's see what that does to surface area. Because most people are going to go, oh, well, if we doubled each one of these, then it should end up being 12. It's not. What is 2 times 2 times 2? 8. 2 times 2 times 2, 8. 2 times 2 times 2, 8. What's 8 plus 8 plus 8? 24. So do we multiply the surface area by 2, like we did the length, width, and height? Or we're multiplying it by a factor of what? So when you increase each of the dimensions, length, width, and height on a prism, when you double them, you're actually quadrupling the surface area. Okay? Oh, I think that was a huge hint. I think I went a little too far. Oops. But I'll be sure to know how many of you watched this video. So I hope you enjoyed. See you for the next lesson.